Okay. So stability of resonance contributors. Let's looking at when we have resonance contributors and we're comparing those Lewis structures. What are the features that decrease the predicted stability so that we can identify the best and most accurate distribution of electrons in a resonance hybrid? So a resonance contributor is less stable if it has an atom with an incomplete octet. Let's write that at the top. So each of these rules can be read in the following way. A resonance contributor is less stable if. I'm gonna go ahead and, okay. So a resonance contributor is less stable if there is an atom with an incomplete octet, there is a negative charge that is not on the most electronegative atom, there is a positive charge that is on an electronegative atom, or there is a separation of charge. That means that you have a positive charge at one position in the molecule and a negative charge at another position of the molecule. That's unlikely because we know that positive and negatives attract. So it would be unlikely for that to be a good resonance contributor when we have separation of charges, which we know attract. So we have some examples for you. Comparing molecule A to molecule B. Molecule A is a better resonance contributor because molecule B has separated charges, and it also has a positive charge on a more electronegative atom. Okay, now looking at another structure. C and D have equally predicted stability. So C and D are equivalent. They both have a negative charge on oxygen. They have a pi bond between carbon and oxygen. In essence, they are essentially the same thing as are all the resonance contributors, but they have the same electron distribution characteristics. And so the resonance structures are the same or equal stability. And when resonance structures are equal stability, that means that the molecule itself is more stable. So when they have equal stability in the resonance structure, that is an indicator, not a definite, that the molecule itself has more stability. All right, let's see if I can get this thing to change slides. Okay, comparing molecules E and F. One of the problems with between molecules E and F is that E is a better structure because F has an atom with an incomplete octet, and it also has separated charges, where molecule E does not have any atoms with an incomplete octet, and it doesn't have any separation of charge. Okay, comparing G and H. H has a negative charge on a less electronegative atom, and a positive charge on a more electronegative atom, which is a less stable structure, because the ideal structure would have either a neutral charge or the negative charge on the more electronegative atom and the positive charge on the more electropositive atom. This molecule also has separation of charge, which is not ideal. Comparing J to I. J has a negative charge on an oxygen atom, where I has a negative charge on a carbon. The negative charge should be on the more electronegative atom. That means that J is a better structure than I. So J has predicted greater stability. Negative on electronegative. Okay. So reviewing the rules again, features that decrease the predicted stability. Predicted stability is decreased if there is an incomplete octet. Predicted stability is decreased if there's a negative charge that is not on the most electronegative atom. Predicted stability is decreased if there is a positive charge on an electronegative atom. And predicted stability is decreased if there is a separation of charge. Okay. Delocalized electron energy. Delocalized electron energy equals extra stability in the compound, because delocalized electron movement, well, we'll have to show you the energy for hydrogenation to explain this, but delocalized electron energy gives extra stability, and delocalized energy only results if there are delocalized electrons. This delocalized electron, the electron delocalization is also called resonance. And so delocalization energy is also called resonance energy. You need to know both terms. And it's important to remember that the resonance hybrid is the true story, and the resonance hybrid is the more stable depiction of the molecule. And the resonance hybrid should be more stable than any of its resonance contributors. Okay, the greater the number of relatively stable resonance contributors, the greater the delocalization energy. So the more resonance contributors you are able to draw, the more resonance energy will be accomplished. And the more equal the resonance contributors, the more resonance energy. So the carboxylic acid has two resonance contributors, and the deprotonated carboxylate ion has two resonance contributors. But it turns out that the carboxylate ion has greater delocalization energy, and that is because the resonance contributors are more equal. So that's the final concept to review. Summary: the greater the predicted stability of resonance contributor, the more it contributes to the hybrid. The greater the number of relatively stable resonance contributors, the greater the delocalization energy, and the more nearly equivalent the resonance contributors, the greater the delocalization energy. So I have a handout that I am going to ask you guys to work on. This is not a formal assignment. This is going to be posted in, let's see, what's the folder called? So I'm going to put this in the extra credit folder, and I will give you any student who attempts the exercise 5 points on exam 2. No, let's apply it to exam 3 because this topic is relevant to exam 3. So what this structure is resonance, learning. It's an exercise that is supposed to help you work through the capability of drawing resonant structures through logical properties that you are already aware of. So part A is drawing resonant structures. And then we have Lewis structures as well and critical thinking questions. And so this exercise is designed to help you become experts at drawing and interpreting resonance structures. It's fairly long. If you don't complete the whole thing, you'll still get some of the credit. And I have an answer key for this exercise. And you can stop at the exercises for part A. So you don't have to go past page 66. You should complete this through page 66, which is page 10 of 16. Okay.